Hello, everyone. Thank you for joining us today in the Global Veritas Challenge 2021 Demo Day, an event organized by the Monetary Authority of Singapore, the ASEAN Financial Innovation Network, and Accenture as part of the Veritas initiative. In this challenge, our goal is to codify responsible AI and drive the implementation of innovative AI solutions that are aligned with the FEED principles, being fairness, ethics, accountability, and transparency across the financial sector. Our 10 finalists have been through an intensive 10-week solutioning phase where they've developed prototypes to their proposed solutions to address 4 key challenges faced by global financial institutions when operationalizing responsible ADA-driven solutions. We are very excited to have you join us today to witness their pitch and demonstrations to their innovative solutions. To kick things off, please allow me to invite on stage our key organizers of the event, Sichun Lee and Colin Sell from MAS's AI Development Office, and James Gunn from Accenture Southeast Asia to share more about the initiative, our journey, and introduce to you our judges who are here to help evaluate our 10 finalists. Sichun, please.
Thank you. Dear all, good evening, morning, or afternoon if you are from a different time zone. I'm Sichun, head of the AI Development Office from MAS. On behalf of the organizing team, I would like to say thank you for your participation. After 8 weeks, we are finally here at the demo day. I hope the past 2 months has been a time of development and learning. We look forward to seeing all you solutions here today. Unfortunately, COVID-19 restrictions means that this event had to be virtual. I would have liked to meet you and view your presentation in person. I would like to thank the following organization for contributing their support to the challenge, whether as a judge, a mentor, or a presenter. This challenge would not have been possible without them. Our partners are Bank of China, Bank of Singapore, Bank of International Settlement, Bank of New York Mellon, Radiant Institute, HSBC, Microsoft, the Personal Data Protection Commission, Standard Chartered Bank, Singapore FinTech Association, and Temasek. I will now hand time to James, who is the Managing Director at Accenture. He will provide an overview of the Veritas initiative and the Global Veritas Challenge. Thanks, James.
Thank you. The Veritas initiative was launched in 2019 to create a framework for financial institutions to promote the responsible adoption of artificial intelligence and data analytics. This framework will enable financial institutions to evaluate their IDA solution against the principle of fairness, ethics, accountability, and transparency, short FEED, that MAS have co-created with the financial industry. Veritas aims to provide financial institutions with a verifiable way to incorporate the FEED principle into their IDA solution. This includes creating a standardized and modular implementation methodology of FEED principle and open source code. As part of the Veritas initiative, MAS, AFIN, and Accenture have partners together to launch this Global Veritas Challenge 2021. The hackathon is the first step towards operationalizing F of the FEED principle, which is fairness. This is part of the overall effort to guide the responsible use of IDA solution in financial services. Key objective is to promote fairness principle into the IDA solution, help financial institutions to incorporate fairness in their processes, and foster the collaboration between FIs as well as solution providers. For this Global Veritas Challenge, together with our supporting partners, we have come up with 4 themes that highlight where responsible ADA solution can be incorporated. Number 1, product marketing. Number 2, risk compliance and fraud monitoring. Number 3, loans origination and KYC. And number 4, credit scoring and profiling. For this challenge, 10 finalists today will be competing for 3 cash rewards of 50,000 each. For the top 3 team, an opportunity to deploy their solution in the financial institutions with the support from MAS, and the opportunity to further expand their solution as part of the next phase of Veritas project. With this, I'm glad to introduce the 10 finalists of the 4 teams. From team number 1, we have AI Career, Visa, and DreamQuark. From team number 2, risk compliance and fraud monitoring, we have 2021.ai. We have Cyclics. For team number 3, we have Experience and UI. And lastly, we have AI Zen, SAS, Tuera, and Demis. I wish you all good luck for today's demo day. With that, I'll pass on back to Colin.
Thanks, James. I'd like to take a look back at our journey thus far. First, we started with the challenge scoping. Numerous workshops were held with a small number of banks to identify key challenges in ensuring the fairness of their idea solutions. From their active participation, we obtained 8 problem statements across 4 challenge teams. The Global Veritas Challenge was launched on 12 July with registrations open for about a month. We received over 140 registrations and 81 submitted proposals. This far exceeded our initial target of 50. Selecting the challenges finalists was a difficult task. We rallied a team of experts from Accenture's Applied Intelligence practice to evaluate all proposals. Shortlisting the 10 best was particularly challenging, as many proposals were deserving of a place in the finals. In the end, 10 finalists from 6 countries in Asia, Europe, and North America were selected. Finalists then embarked on the 8-week solutioning phase, where they developed their prototypes under the guidance of a mentor. Finalists also underwent masterclasses on the Veritas initiative, industry insights in the area of responsible AI, and an overview of the fintech landscape in Singapore and Southeast Asia that was conducted by the Singapore Fintech Association. And everything ends here today at Demo Day. Finalists will be presenting their work to the judging panel. We go on to the evaluation criteria. There are 6 main evaluation categories. First, the fairness objective. Has the team defined the significant harms, benefits, and at-risk groups in relation to the problem statement? How has the team demonstrated that the system will operate in alignment with the fairness objective and account for what is achievable with their solution? Has the team also analyzed the trade-offs between the fairness objective and any other business objectives? Second, team experience. Has the team demonstrated their ability or experience to implement the solution at scale? Third, presentation quality. How engaging was the presentation and was the solution well demonstrated? Fourth, solution feasibility. How does the technical system design of the system help ensure it continues to operate in accordance with the stated objectives? Is the proposed system also implementable at scale? Fifth, solution desirability. How much impact will the proposed solution have for financial institutions trying to implement the fairness principle within their operations? And finally, effort. How well has the team articulated their approach in developing the tailor-made solution for the challenge? I will then pass on the time to Wayne from Accenture, who will take you through the demo day format. Thanks, Wayne.
Thanks, Colin. So first thing I want to do is to actually introduce our panel of judges that we have on board. So these are leaders for various financial institutions, government bodies, and major technology providers. To name a couple of leaders, right, from Bank of Singapore, Standard Chartered, HSBC, to Temasek and PDC, and even Microsoft. So without further ado, I'd like to introduce our panel of judges. To start off with, we have Lee Jun Seong from Accenture. We have Celine from Bank of Singapore. We have Jenny Premio from Bank of International Settlements. We have Hans Brown from BNY Mellon, Lachlan McCullen from Gradient Institute, Gunjan Bhatt from HSBC, Nick Lewins from Microsoft Research, Zikin Yong from PDPC Singapore, Marie Rossish from Standard Chartered, Ben Siseki from Temasek, and lastly, Johnson Pohl from UOB Group. We'll now give them a couple of seconds to introduce themselves to all of you.
Thank you very much. Very happy to be here. This is Jun Seong. I'm based here in Accenture, Singapore. I'm responsible for the data AI business called Applied Intelligence in Southeast Asia. Very good to see everyone.
Thanks, Jun Seong. Celine, care to introduce yourself?
Welcome everyone to the challenge. I'm Celine Lecotenac, the Chief Data and Innovation Officer for Bank of Singapore, the private banking arm of OCBC Group, and looking after the data strategy of the bank, including data architecture, AI and analytics, as well as data management and governance.
Thanks, Celine. Jeremy.
Yes, thanks, Wayne. So Jeremy Pranyu here. I'm Principal Advisor at the Financial Stability Institute of the Bank for International Settlements here in Basel, Switzerland. So I basically coordinate all our technology-related policy work. Thank you.
Thanks, Jeremy. Next, we have Hans Brown.
Morning, everybody. My name's Hans Brown, and I'm responsible for enterprise innovation for Bank of New York Mellon, which comprises of all the work we do in our innovation centers, our principal investing in emerging fintech companies, as well as our ability to create new businesses. I also double up as the Chief Information Officer for Corporate Technology, and really excited to be here and looking forward to seeing what everybody's got to show.
Thanks, Hans. Lachlan, please.
Sure. Looking forward to tonight. My name is Lachlan. I'm Chief Practitioner at Gradient Institute. I'm a machine learning researcher, and I lead Gradient Institute's training, system development, and assessment functions.
And next we have Gunjan Bhatt.
Thank you. Great to be here. I'm Gunjan Bhatt from HSBC. I lead the data analytics and CRM practices for Singapore and some of the other Asia Pacific markets for the wealth and personal banking, the retail banking of HSBC. Really excited to be here.
Thanks, Gunjan. And Zikin, could you introduce yourself, please?
Hi, Zikin here, Deputy Commissioner, Personal Data Protection Commission. Happy to be part of this panel to see how we can work towards fair, responsible, and explainable AI. And we do what we can to support the use of data and the use of data-driven technology like AI.
Thank you. Next, we have Marie.
Hello, everyone. I'm Mary Rostik, and I'm Chief Data Officer for Standard Chartered Bank. Really excited to be here and to look at all the projects and how we promote responsible AI across the ecosystem. Thank you.
Thanks, Marie. Next, we have Ben.
Hi, everybody. My name is Ben Siseki. I'm part of the Temasek AI team, where we look after strategic investments, building domain expertise, venture builds, and then, of course, also partnerships on AI ethics and governance. I'm super excited to be here today and really looking forward to the different pitches of the teams.
Thanks, Ben. And lastly, we have Johnson.
Hi, everyone. Johnson here, and I help drive the Group Enterprise AI and Data function at UOB. The function serves as a center of expertise at UOB, and we help oversee our group AI and data analytics strategy, AI governance, data partnerships, as well as the development of in-house data science and machine learning capabilities. It's a pleasure to see everyone gathered here today, especially so when most of us have been operating remotely across Singapore as well as the region. So thanks once again for having me here as a judge for the Global Veritas Challenge. I'm looking forward to learn from your proposals.
Thank you, Johnson. Here's how Demo Day pitches are going to work. Just a reminder, so each team will be sorted into 3 presentation waves based on their chosen problem statement. And each of them will have 5 minutes to pitch and demonstrate their solutions to our panel of judges, followed by 7 minutes or so of question and answer, Q&A. In wave 1, right, we'll be seeing Icadium, DreamQuark, and Visa tackling the challenges of bias in product marketing. In wave 2, we will see 2021 AI and Xilinx tackling risk compliance and fraud monitoring, while we're also seeing Experian and EY on loan origination and KYC. Lastly, In wave 3, we will see Eisen, SAS, and a tag team between True Era and Demise talking about credit scoring and profiling. So without further ado, let's bring on our first team, Arcadium, into the room to begin their pitch.
Good afternoon, everyone. My name is Victor from Arcadium, and I'm very excited to showcase to you today our solution for the Global Veritas Challenge Hackathon. Jumping into the background of our hackathon problem statement, we are working on the theme of product marketing, problem statement 2, and our data set is around the marketing campaign data for the Portuguese bank from Kaggle. So the use case is to predict whether a customer will subscribe to a term deposit or not, and then this will then help the product marketers to target the right customers and to save marketing costs. Therefore, we framed the goal of our solution around helping the product marketers to find the optimal balance between business and finance objectives, where we define the business objectives as to for the banks to maximize profits and to minimize costs. And for finance objectives, it's defined as to maintain the fair values of equal opportunity, which is to mitigate the loss opportunities for the customer, and to, predictive equality, which is to mitigate the lost revenues for the bank. So with that, we propose the following solution that comes in 2 parts. Number 1, a model card designed to assess an ML model's alignment with the FIT finance principles. And number 2, an MLOps platform that orchestrates the end-to-end AI build, operations, and governance that powers the model card. So without further ado, let's take a look at the video clip.
In this model card, each section corresponds to a component in the 5-part methodology to assess alignment with the FIT fairness principles. The first 3 sections describe the problem at hand, the dataset, and the modeling process. They allow the data scientists to gain insights into the model and into the data through interactive visualizations. The 4th section compares the business objectives, which are maximizing profit by increasing investment revenue, with the fairness objectives, which are maintaining fair values of equal opportunity and predictive equality. On the sidebar here, the user can set custom business variables such as average investment levels, revenue percentages, and costs. There's also a section to select the fairness variable between privileged job and tertiary education. The first part of this section calculates optimal profit levels without taking fairness into consideration. The graph displays how the business objectives as well as the fairness objectives vary with the threshold, the maximum profit level, and the corresponding fairness values are presented here. The next section allows the user to optimize profit while taking fairness into consideration. This is dependent on the business variable set here, as well as you can select the personal attribute to consider and the weights for each fairness metric. Then you can click the Optimize button. Clicking the Optimize button runs a Bayesian optimizer, which provides the optimum values for profit and fairness. This allows the user to get a quick view at the optimized profit levels when fairness is not taken into account and when fairness is taken into account, as well as the fairness levels for both these scenarios. Here we can see that the profit levels don't change much when fairness is taken into account, but the fairness attributes improve significantly. The calculated threshold for optimized fairness are automatically plotted into this calculator to calculate business metrics and additional fairness metrics. The user can fiddle around with the thresholds by moving them along the slider. These automatically update the business metrics and the fairness metrics. The next section deals with the personal attributes and the bank's policy of choosing these. The last section provides the data scientist quick links to the training pipelines, where end-to-end review is made possible. There are 4 model versions being monitored here. Each version could be modeled and monitored on a weekly basis or with different competitor rates, term rates, etc. There's also a link for endpoint monitoring. The users can view the latest model metrics and monitor the model performance over time. Additionally, the users can regularly monitor fairness metrics and see if they are within an acceptable range. If there is more than a 10% deviation in the fairness metrics, alerts will be triggered to the data scientist to retrain the model.
So I hope you enjoyed that clip that demonstrates our model card. The clicker is not working. Okay, right. So let me touch upon our second part of the solution, that our MLOps platform. So this is actually a live platform currently in use by our customers and is designed for scalability. So it comes in the form of a managed cloud infrastructure that supports multi-cloud and harnesses infrastructure as a code for easy deployment on AWS and GCP. Secondly, it is designed on top of a microservices architecture for the ease of integration and monitoring, starting with 1 models and scaling to hundreds of models. And finally, we built in enterprise-grade security for the peace of mind of retaining control over sensitive data and code. So to sum up, these are the key benefits of our end-to-end turnkey solution for implementing the FIT fairness principles. Number 1, we have a model card with a guided flow that tailors the views for business and data science audiences. Secondly, we built in the trade-offs to be explored easily via the interactive visualizations. So this enables even non-data scientists to quickly see for themselves the impact of the trade-offs between the business and fairness objectives. And last but not least, we make it scalable across AI models thanks to the effortless deployment enabled by MLOps platform with the comprehensive monitoring capabilities. And with that, thank you very much, and we'll open the floor to questions.
All right, thanks very much for the presentation, Team Icadium. And judges, if you have any questions, please feel free to raise your hand. The 7 minutes starts now. Okay, so we already have a couple of questions coming in. So Celine, feel free to go.
Yes, hello, interesting presentation. I would like to know regarding the, have you already implemented your solution in any financial services institution, or have you done a small scale POC already?
Hi, Celine. Victor here. Let me take that question. So this one is very much an R&D project for us that we want to eventually build into Bedrock. So our MLOps platform. Our MLS platform, I think it is actually in use in, rather it was being trialed out at some of our banking customers previously. But for this fairness model card itself that is specifically tailored for banks, this is something that that's why we joined this hackathon, and we did work closely with our mentor, Ronald Joy from HSBC, to kind of tailor this whole experience for an actual user. Yeah, but so yeah, this solution itself is not yet deployed in any of our customers.
Thanks, Victor. And next question from Deacon.
Yeah, thanks for the presentation. I like the model card. It's very intuitive, easy for us to understand before we deploy. So my question really is around post-deployment. How do you monitor to make sure that the performance is actually as expected, right? So that you can take any corrective measures after that. So can you share with us how you intend to do that?
Hi, Ziki. Would you like to take the question on the monitoring after deployment?
Sure. Okay. Yes, I can do that. Once the parameters of and the model has been deployed, we can start to collect the inference and the features as the model endpoint is working to collect the data. So we can schedule the training of the model on a monthly basis, on a regular cadence, and we will check the performance with real-time data for example, on a weekly basis. And we can in our MLOps platform, we can compute those business metrics as well as the model performance metrics and fairness metrics, and send them to the model card that you saw earlier. And therefore, you will be able to monitor as time goes on the time series of all the metrics that you're interested, or the business owners are interested in, to the current date.
Thanks, Kok Ming. Zikin, I hope that addresses your question. Great. And we can probably afford to have one or two more questions. So maybe we can have Gunjan, you can go first.
Hi, thanks. Thanks for sharing. Appreciate all the effort. A question from my side. I think the model piece is taken care of here. There are times when campaigns happen based on pure rules or event triggers or something like that. Does this have the flexibility to incorporate some of those elements in, meaning the pure data and analytics side, not the AI ML model side?
Gunjan, thanks for the question. Pankui, would you like to take that?
Sure. Thanks for the question, Gunjan. So the first two parts of the model card were not displayed just because they're short on time. So that talks about the data section of the model and of the marketing campaign. So what the model allows us to do is you can take a quick glimpse on how the data is looking, visualize each of the features within the data set, and then see how each of those data points are affecting your outcome variable. So you have a detailed visualization of each of your feature variables, which should provide help in marketing campaigns when you're not able to use an ML model. So pure data analysis is available there. Yeah. I hope that answers the question.
Gunjan, you were on mute for a second there.
Sorry, no, thank you. I'm good. I'm done. Thanks.
Oh, okay. Thanks, Gunjan. So we can take on one last question from Hans, please.
Thanks. Really good presentation. The thing I'm wondering is, I looked at the representative data set that you guys use to validate or to run the. How representative do you think that data set is, from its wider application? Or is it, or do you feel like the model, what you have at the moment now, will scale beyond, just dealing with that specific data set?
Hi, thanks, Hans, for the question. On the data set, maybe Pankwi, if any comments around that, then I can take up the scalability side of things.
So the data set is more specific to the Portuguese banking institution. However, it does have some very common features such as demographics, like your age, marital status, etc. And then there's information about previous marketing campaigns and upcoming marketing campaigns. So I think in terms of applying this to different data sets, to separate marketing campaigns, what can be done is, as soon as we change the data, you just change your feature. So you have to retrain the model, but it is possible to apply a similar model card to different data sets. All you have to do is probably retrain the model a bit and figure out what your fairness features could be accordingly. But it is possible it is flexible enough to be applied to different data sets.
And to add to Pankwi, so on the scalability side of things, if you are scaling up in terms of the number of models across the number of data sets, I think that is very much possible. The model card itself is going to be one of the, we envision it to be a template that is deployable and configurable when you deploy a model on our MLOps platform. So we will make it generic and or rather, depending on what the use case is, then the model cards can definitely be modified to suit the different data sets or the types of models. Yeah, so scalability itself, that is not an issue.
All right, thank you.
Thank you. So right on time, 7 minutes already. So if there's any further questions, feel free to let me know, and I can always forward it across to the Icadian team. But for now, thanks so much, Icadian team. We'll send you off, and let's prepare for our next pitch of the day with Team Visa.
Good afternoon. Today, I would like to talk about inclusive AI and the business value of AI fairness. Though we're specifically focused on product marketing examples in this presentation, we strongly believe that this toolkit is completely scalable and relevant to all the problem statements in the hackathon. Before we actually dive into the solution, we must understand who we built this for. Firstly, we have AI developers or data scientists who build models within financial institutions or external vendors. Then we have AI deployers who are model owners and are ultimately responsible for the outcome of the AI solution. And finally, we have oversight teams who manage model risk, and through materiality assessments, they ensure that the AI solutions deployed don't cause unintended harm. So the three stakeholders have a shared accountability to protect the customer from the unfair outcomes of AI. In product marketing, we don't always want to include all groups, as some ads may also cause harm to vulnerable people. So there is no universal approach to fairness, and the fairness constraints for every model must be decided on a case-by-case basis. This is why we have adopted a flexible perspective on fairness. Fairness is a very difficult concept to grasp. There are mathematical, legal, and ethical definitions of fairness with conflicting outcomes. At present, AI developers train models through completely fairness-unaware machine learning pipelines. So there is a need to introduce better accountability and transparency in the model building processes so that the deployers and the oversight teams can make better decisions with AI. In the context of product marketing, the individual fairness or winner takes all may be the most obvious strategy. However, always adopting this strategy in product marketing could also deny groups from accessing basic services. So although in the short term, the profit of an AI-powered marketing campaign could be maximized by targeting groups that more frequently subscribe to a service historically, the customer lifetime value for a financial institution improves when we include more demographics, provided that the product is not risky for the customer and the basic financial constraints for the requirement are met. Therefore, we have built this toolkit as a completely data, model, and platform agnostic scalable tool to enable stakeholders to arrive at fairness decisions in consensus. We acknowledge that this is not purely a technical problem. It is a governance problem as well. So a piece of code alone is never going to solve the issue. What is different about our tool is that we've made many of the SDKs that are out there can be quite technical. So we have made a more business-friendly and domain-relevant tool for AI developers so that they can shift from fairness unawareness to training models with fairness routinely. And among our innovations, we have extended the Microsoft FairLearn library and also provided some Visa proprietary algorithms. And we're also providing data scientists with end-to-end examples on fairness tutorials and product marketing. Our key differentiators is that we see our toolkit as an enabler, and our focus is on the end-to-end and the AI stakeholders and their needs. We also have a world-class team of domain experts and data scientists who pulled this entire toolkit together in 6 weeks. So we think that we can scale this and operate this within a secure sandbox as part of routine ML operations. So how we see this effort, we see it as an industry standard for practitioners to help them train models with fairness across the financial sector. So finally, to motivate the business value of fairness, I want to show you a demonstration video where we showcase how we adopt different fairness strategies to make term deposit products more inclusive.
The Visa Fairness Toolkit is a stakeholder-centric approach that enables AI developers, deployers, and oversight teams to have a shared accountability model towards arriving at the best decision for AI fairness. AI developers want to incorporate fairness workflows more intuitively and seamlessly into their model building. So we provide that by showing them, for example, fairness accuracy trade-offs. If we look at this scatter plot, data scientists and developers can pick the top models that meet both their fairness and performance goals. They can ensure accountability and explainability by understanding what are the top predictors driving positive and negative outcomes. We provide AI developers with a dynamic tool that enables them to compare the unaware fairness models against all the fair options we provide combinatorially. AI deployers, who are also typically decision makers or product owners, also want to understand how fairness is going to impact their business success. When we look at the top graph, we can see different models that have been trained with different fairness parameters. We have unaware models that don't have any constraints on fairness, individual fairness models that have had sensitive attributes and protected classes removed, and group fairness models that are trained with different constraints against protected classes. In the long run, if we look at the profit of each individual campaign, although the unaware and individual fairness models may have a higher profit in the short term, we can also use the Visa Fairness Toolkit to quantify the long-term value of fairness. In addition to that, AI deployers can also understand how the different models trained by data scientists are targeting protected classes. Finally, oversight teams such as model risk management can also use this toolkit as a decision support tool that would enable them to assess which models pass the performance, fairness, and business criteria before the models are deployed externally. So this is how together we have enabled all of the stakeholders to arrive at a decision on AI fairness with shared accountability.
Yes. So just to summarize, right, we spoke about AI developers, deployers, and oversight teams, right? So in the past, they had challenges in making pipelines fair. So what we've provided is a toolkit to intuitively blend comparative fairness within their existing technical workflows. Deployers can now understand the business value of fairness by having a quantitative metric alongside the fairness parameters. And oversight teams can have better audit trails and accountability because one of their struggles is that they typically don't have very consistent documentation. So this is how our toolkit is helping these stakeholders come together to safeguard and protect the consumer.
All right, thank you, Nuri. That's great. Judges, Any questions for Team Visa? Lachlan, go ahead, please.
Hi, Nuri. Thank you so much for that presentation. I really liked the way you described the potential harms that one could create by deploying a marketing system. I'm wondering if you could speak a little bit about how a user of your tool might go about constructing the quantitative measures that they have for those harms in your system.
That is a great question. So I'll provide a perspective, and my colleague Ajit, if he has anything to add, he can. So I think, this is not only a mathematical problem, as we said, the ethical part and the societal part comes into play as well. But if I was to start with a quantitative metric, in the dashboard that we showed, we had different views for the deployers and the oversight teams. So in the oversight view, maybe I could just share that if it helps. Anyway, maybe I can just talk about it, given the slides are not here. So we have different fairness metrics that look at, for example, demographic parity and equalize odds. But in isolation, I don't think they're a very accurate depiction of the risks and harms to a customer. So I think at the beginning of the process, we also conduct a harms assessment and try to link that to the actual quantitative output. But I don't know, Ajit, if you would want to add to this as well.
Yeah, the way we have structured is we took the 3 data sets which were provided and we picked up like the term deposits, and with a term deposit product, how we are marketing it, and we try to understand what are the harms and benefits of that particular product, and using that as a base, we come up with a set of metrics or fairness constraints which we could apply on the model to make sure that the model is fair. So the choice of the fairness constraint depends upon the use case which you are trying to solve for. So what we have put together is a sample set of fairness metrics as a part of this hackathon.
Great, thanks.
Thank you. Before we move to Junseong, is it okay, Zikin, if you could ask your question first?
Yeah, one question. In one of the slides, you showed the difference between the individual models and the group models. And you said that for the group models, in the longer term, it might actually be more beneficial. How do you plan to collect the data that will support that and to convince your the AI deployers of this? So that's my question.
So I don't think group fairness is always the strategy we should be adopting. I mean, because individual fairness is also appropriate when we're trying to remove the dependency from models on protected classes, right? So I think the key point that I was trying to make is that this has to be done on a case-by-case basis. So our toolkit, the idea of that slider that I showed is that there is no right or wrong, right? A materiality assessment needs to be conducted, and the risks and harms of the solution that is going and how it's going to impact the consumer need to be identified upfront, right? And then based on that, rather than training a single model and saying this is the output, AI practitioners should have different model combinations, and together with the stakeholders come out on a consensus for the right fairness strategy. So to answer your question, Zikin, I think that perfect demographic parity in some cases could even be harmful, especially in product marketing, because we're trying to ensure that certain groups, like for example, children, don't get harmful ads, right? So I hope that that answers your question.
Right, next we have a question from Johnson, I believe.
Hi. Yeah, I think my question is a follow-on question on the fairness measures. I'm just wondering, I guess you have mentioned a few fairness measures already, but I'm just wondering, what kind of fairness measures are actually used in this particular product marketing use case? And then at the same time, is this tool capable of advising the users on how we can apply the different types of fairness metrics in the most efficient and relevant fashion?
Sure. No, I mean, so for simplicity in the specific toolkit, I use the demographic parity ratio because this is a metric that is easier to interpret. If, I mean, you're close to 0, it's sort of unfair. And if you're close to 100%, then you could say that you're fair. But I don't think that a single metric in combination solves the problem, right? So the idea is that an AI developer would probably see the entire plethora of metrics that exist. So there's the equal opportunity ratios, there are the differences as well. And the Fair Learn and the Visa Fairness Toolkit also output all of those. But in terms of simplifying the decision, it depends on the stakeholder who looks at them, right? So I had a lot of trouble thinking about which was the right metric to show because every number that we show also comes with a lot of technical baggage. But I would think that, I mean, we should definitely pick the simpler ones that are easier to understand. And depending on the stakeholder, we would increase the complexity. So there is no end to how many metrics we can show, but right now from the back end, we actually have all of the main ones in the literature.
Right. Thanks for the answer. That's the reason why I thought the previous question on the harms and benefits, on the benefits and harms assessment will be relevant because it is that understanding of the benefits as well as harms that will determine or help guide what kind of fairness measures will be most relevant when it comes to the solutioning.
Yeah, like within this prototype, we defined the fairness metrics which were relevant to the problem statement which we had. But then going forward, definitely there are opportunities to include those 100+ different fairness metrics we would have. And then a data scientist would get a suite of fairness metrics. And then all the stakeholders could sit together and, okay, this is a problem which we had to solve. Here are the different fairness metrics, 10 fairness metrics which we need to consider. And using those fairness metrics, you then train multiple models. And based on those models, all the stakeholders then take a decision saying, okay, this model with these fairness constraints, given these outputs and these insights is what we would actually deploy.
All right. Unfortunately, that's all the time we have on Q&A. I'm so sorry, Jun Seong and Marie, but we have to move on to the next presenter. So with that, thank you so much, Team Visa. Greatly appreciate your presentation and your time. Next up, we have DreamQuark.
Thank you very much for selecting DreamQuark for this final. What we want to present today is our answers to this challenge of how we build further AI specifically for the financial industry and the use case of product marketing. DreamQuark is a 7-year-old company based in France that works specifically with financial sectors. And we developed a software that enables our customer to create, deploy, and monitor responsible AI solution that help their advisor sell more. There are several challenges that we have identified regarding fairness, specifically the fact that we need to identify fairness issues. We need to create models that are fairer but do not have impact on business performance, and we need to monitor fairness over time. At the same time, we see that while companies are adopting AI, their regulators are expecting from them more fairness, but most of the time they are more focused on delivering the value proposition for the customers and willing to innovate. We present with Thomas today our proposition for more responsible AI in production.
Okay, so take a marketing use case. Let's say you want to, is the video playing? Yeah. Let's say you want to predict which of these 60,000 clients earn more than $50K. Here we get the predictions of the first model trained regardless of fairness objectives. The dataset has a strong selection bias against women. Our fairness tool, FairDream, detects potential unfair issues on it. Discrimination alerts are launched only if the marketing segment is 4 times less selected by AI than mean. You are alerted that education, work, and gender are biased. And you can notice that FairDream alerts are also adapted for the data scientist user that can check feature distributions and biases with our transparent tools. Now, how do we do to correct the model? It's human in the middle and assessed on Apex. In just a few clicks, you enter your marketing and fairness preferences, the sensitive features, you choose the biased element, here sex, among those that have been highlighted by FairDream's alerts. Then you enter your fairness vision. So for this, simply, you are guided by FairDream tools to choose a matrix corresponding with your vision. Say you want to make percentages of individuals by groups, women and men, selected by the model equal. So FairDream advises you to use equalized odds in this case. And you finally enter the costs and benefits of a new client so that FairDream evaluates and selects the models with our customer return on investment metrics. And then with the processing, we automatically, with FairDream, train models and recommend the best to rebalance the targeted segment. Now, you can see that FairDream is quickly searching for fair models to adapt to your business fairness trade-off. You see that several models are competing, and in the summary, you see an important fairness chance with no drop in return on investment that is still around 1.4 million for the user. And then you can test with our deployed API and see that a Black woman with 45 years old and a PhD that previously was discriminated by the baseline is now no more discriminated after we choose a recommended model. And the API is deployed on IPX2, I will add. So you can switch to the slide to Geraldine, yeah. To sum up, so after alerting, based on user choices on sensitive features, sex, and fairness vision, FairDream trains and recommends a new model. And even in this extremely biased model that excluded women, then 13% more women are selected, and FairDream ensures there is no drop in return on investment. And as a conclusion, FairDream is a user-guided AI solution that empowers the user and ensures fairness. Based on the deployed explainable solution, we have added fairness with a multi-stakeholder approach: regulators, data scientists, business analysts, and business users. Thanks for your attention.
Perfect, right on time. Thank you, DreamQuark. Judges, any questions for the team? Ben, go ahead, please.
Yes, thank you. Well, thank you so much for the presentation. I thought that it was really compelling, and you made a couple of really interesting, well, I guess, claims. Let me sort of double click on one of them, which I found particularly intriguing, when you said that the system actually provides a recommendation with regards to the fairness principle or the fairness KPI/metric to apply for a certain criteria. Possible to explain a little bit more how that recommendation comes about in the background?
So Geraldine, if you switch to the slide, I don't know if it is a slide concerning processing. Can you switch? Not this. After. Okay, so this. So you have like a tree. So you can zoom on it, Geraldine. Okay,
no,
no. So we have a tree. So it's optimized. When the user says, for example, that he wants to optimize, and that is the fact that the base rate, so the percentages of individuals between groups are equal in the reality, then the answer is yes or no. And then the user can choose a representation of inequality that is, for example, quantitative or equal numbers of proportional. And then with all ramification and choices, we with FairDream advise a fairness matrix. That is, for example, when you say that base rate should be equals between groups, and that the representation of inequality is proportional, with FairDream we advise demographic parity automatically. Okay, so it's like a ramification. I don't know if it answers to your question.
Thank you, Ben, for the question. I believe we had one from Lachlan as well.
Yeah, thanks very much for the presentation. I think I saw a slide that said you can achieve what looks like group fairness constraints with no drop in performance. Was that, did I understand that correctly?
Yes. So basically, what we aim, not what we aim, but what we do at Dreamquark is that we focus on product marketing. So we have an advisor portal for specifically advisors, and behind the scene we have all these models that can be built through an AI platform. And what our customer is asking us is, if we use fairness, we don't want to have a really fair model, but that doesn't create return on investment for us. So what we do during the process is that we optimize for different metrics. Obviously, we have this fairness that is one metric that is absolutely constrained in this case. But on the other side, we are generating different metrics like false positive rate, the return on investment that the model envision, and we minimize the impact on performance that the correction of fairness will create. So sometimes by having also some person that move from a category where they are excluded to a category where now they can have access to some product, you could even get an increase in return on investment, because some customers that were not targeting now could be targeted and become potential buyers.
Thank you.
All right, we have time for one last question from any judges. Salim?
Yeah, hi, hello, thanks for the presentation, very interesting. I mean, in the current state, right, of a Python notebook being used, how do you think, scalable is that solution, and how can it be used by the other stakeholder that might not have like programming language, in terms of what is your envision of product development when it comes to making this more democratized usage across, different group of people and not only the developer itself?
Yeah, so basically our solution is first intended to non-technical users. We also have a dashboard, so not the one we show, but the platform that Dreamquark built. And at the same time, we have a specific dashboard for the end user, which are investment analysts or relationship managers that get access to the score and can deliver the value of this course. What we saw also is that a lot of data scientists are willing to use our software. So we built a SDK specifically for data scientists. And because we've seen a lot of organizations that data scientists are the first to look for these tools, we first built an extension of our solution for data scientists. But we can scale it through Dreamquark Brain, where we have the 3 stages. First, preparation of the model and training, which is completely automated with automated machine learning in the middle. Then we have the generation of AI governance that provide, for example, explainability already at scale, and third, monitoring. And we will implement in our workflow these techniques that we have developed to make it available to other users and data scientists.
Yeah, because we developed these processing techniques specifically for the challenge. So that's why Brain and our products are generally scalable and deployable, and it's the logically next step for these new fairness tools that we developed thanks to you.
That would be a kind of new feature, if my understanding is correct, of your existing Brain platform that is already implemented in existing financial services institutions.
Yes, exactly.
All right, perfect, just in time. So thanks again for the great presentation, Team Dreamquark. And with that, we actually close off the first wave of presentations on product marketing. So big thanks to Dreamquark, and we will send you off right now. Thank you.
Thank you for this opportunity.
Big thanks to you. It was very exciting challenge.
All right, so up next, we have presentation wave number 2, which comprises of 2 challenge statements. The first one we'll be tackling will be risk, compliance, and fraud monitoring. And the second will be loan origination and KYC. The 2 groups that will be tackling risk, compliance, and fraud monitoring will be 2021 AI and Xilinx. followed by experience and EY with loan origination and KYC. Kicking things off with 2021.ai.
Yeah, thank you very much. And welcome to our presentation on bias detection and mitigation for fraud detection in financial institutions. As you might all know, fraud is a big problem or challenge for financial institutions. We see that both in Singapore, but also in the UK and a lot of other countries, where institutions try to build models that detect fraud. But on the other side, we also have a challenge that bias inside these models might be an issue. And we know from frameworks like the FEED assessment that unintended bias in these models should not be present. And hence that we entered the challenge to present a solution that on one side detects fraud, but also allows for mitigating and detecting bias. And this is what I would like to present to you in the next couple of minutes. This diagram shows in essence what you will see in the live demo that I will come to in a couple of seconds. So first of all, we will have a look on the FEED assessment as setting the general frame. We'll then show you through a bias assessment that management can define bias variables or variables that need to be checked for bias to the development team. Both of that lead into reporting so that it's all immutably stored in the system. The data scientist then starts the development, and at one point of the first round of development, he or she will use an application that will help to, first of all, detect bias. And if bias is present, then that system will help the data scientist to mitigate that bias. And after that, it will both allow for reporting this bias mitigation and testing. So it feeds back into the feed framework, allows to use it as a source basically, but it also exports the then mitigated model so the data scientist can go further on with deploying that model in production and so forth. To demonstrate the solution, I would like to play a short video that shows you this.
In the beginning, we set the frame with the FEED assessment. We then use a bias assessment to define high-risk variables. This will be reported, and the technical teams now select the data and the model. They define the target variable and the high-risk variables. Here we have gender and age group. They then select the bias detection method, and we can see that we have a slight bias when it comes to the gender variable. Beside that, the model performs very well. Now we go on to the bias mitigation. We can choose from multiple mitigation methods. We mitigate the bias. We see that the model performance drops, which is normal when we mitigate bias, but that we remove nearly the complete bias. We finally can export the model for further model productionizing steps, and we can export the results as a PDF document and link that to the assessments of the management so it feeds back to the reporting.
Right. So that was our short demonstration. And to sum up, what we showed is, first of all, an integration of our solution and a linkage to the feed assessment. We then showed a complete governance reporting package that both takes into account functional, technical bias detection mitigation, but also links that up with governance reporting to management, as well as allows to give some supervision from management on to the development teams. We showed an overview of the fairness objectives and the trade-offs and how this develops with the bias mitigation. The whole system is usable at scale on the one side because it's adaptable to any type of classification problem, being a churn or anything else. And the whole solution is based on the Python framework, and through the integration of MLOps pipelines in the system, it allows for running these automatically. So with every retraining, one could run through this kind of execution of bias detection and mitigation.
All right.
So in addition to that, our team is quite experienced. We run this type of solution or similar solutions, not exactly that one, but similar ones with more than 50 clients, from which some are also global financial institutions. We're originating from the EU, but moving now more and more into the Asian market. We have strong collaborations with the EU, where we are running research projects together with them in, related to AI governance, as well as with the ICO in the UK. And well, that being said, finally, well, several millions are lost in fraud, and being able to detect fraud by having no risk and bias is a key for financial institutions. And with our solution, well, we showed that you can do both. Thank you very much.
Thanks, Bjorn. Judges, any questions, please? Johnson, go ahead.
Hi, yeah, thanks for the presentation. It was a very interesting video clip that you have presented. My question relates to the fairness threshold. So how do you actually decide on the relevant threshold to apply with regard to the fairness measure and with regard to how you want to actually mitigate this bias?
Yeah, I think that's a good question, and related to this fairness threshold. So for this application, for the prototype, we followed the literature on, first of all, on which fairness metric is the appropriate one for fraud case, and then also related to this threshold. Obviously, if we would think about scaling this probably to other cases like churn, which is a little different. We need to treat it a little different. Then a further development of that prototype, would be to implement a technical selection criteria or technical support for selecting this metric. Yeah, but for now we also rely on the data scientists to select the right metrics here.
All right. Next up we have Lachlan. Please go ahead.
Thanks very much. Just following on from that, you talk about the data scientists selecting the metrics and the thresholds, and also sort of being the main person that involves like doing the work with this tool. But to me, it seems like the choice of what fairness measures to consider and how they should be balanced against other objectives and is really one for the system owner, or it's more about encoding the values of the business into the system rather than like a mathematical property of bias. So is there a way for the business to kind of understand how your system relates the harms and benefits of their system to these bias mitigation and detection algorithms?
Yeah, I think very relevant point as well. So first of all, for sure, the business should be involved here, right? Setting the standards. We showed that in the beginning with selecting these high risk variables, which would obviously come from business. Now we could do kind of the same approach and adapt the tool towards that business is also setting maybe the thresholds or defining how much trade-off we can accept here in terms of accuracy. That is one side. The other side, in terms of the actual detection method, I think there it's still well, some research to be done on if there's a way to do it easily without statistical knowledge, because to properly select these detection methods for bias, one needs to understand a bit the principles behind it. So that's why we still had it relying on the data scientist. But
right, we have time for one last question from Celine.
Yes, hi, hello. You were saying that you're working already with 50 existing FSI, right, client in your various market. What is the current solution that you are developing for them? Is it fraud anomaly detection?
Yeah. So what we supply, I mean, it depends always a bit whether we also supply you could say a model. We have as a core offering MLOps platform with extensive governance functionality, which includes the logging engine of certain performance metrics, includes the ability to adapt or implement assessments where we supply assessments from the ICO, from the Danish FSA, where we run a pilot project currently with a pension fund, but also from the EU and so forth. So it's quite a versatile framework. And then we sometimes also supply models like AML or fraud models, but also on the customer side with churn and churn detection models.
And can you, if I have a bit of time, can you elaborate a bit more on the ability to mitigate the bias, right, that you have shown as one of the functionality of your product?
Yeah, absolutely. If the time allows that. So as you saw in our prototype, we allowed for 3 different types of bias mitigation, which is the in-processing, the pre and post-processing, and we allow here obviously also the addition of more processes here. The pre-processing basically works in a way that it changes the balance of the risky classes or protected attributes in the data set. So it works with the input data, changes that there, and then with that mitigated. The in-processing works with actually changing the model. So we'll technically train another model on top of it, which then aims to have less bias. And the post-processing is working with the weights basically of the predicted classes, and then sees that there's no bias, very simply speaking. And the way we build this is that we can actually add here more and more, for example, post-processing methods once they come up in research. So we're also here set up in a way that we move forward with the research and the new approaches that probably will come in the next years.
Thanks, Bjorn. All right, and thanks, Celine, for the great question. So let's wrap up and thank 2021 AI for their time. So thanks so much. And we're going to bring in our next team, also tackling the challenge statement of risk, compliance, and fraud monitoring. We have Xilinx.
All right, good morning or good evening, everybody. I am Timothy from Xilinx, and it's my pleasure today to introduce Verify ML, our open source toolkit to help financial institutions implement responsible AI workflows. So the main problem we're trying to tackle is the following. How can fairness be incorporated in an algorithm's development, data handling, and production process to ensure no unintended biases? We took the following approach when tackling this problem. We look at existing research papers, interview expert mentors from financial institutions, and examine open source solutions and other tools. We felt that a lot of these tools and frameworks were delved too deeply into metric-driven measures and were not really complying with the MAS fairness principle and spirit. Thus, we created Verify ML to help bridge the gap by creating a more holistic approach that encompasses operations, machine learning development, as well as production. So Verify ML is an open source governance framework and Python library to help you build reliable and fair IDA models. With more than 5 classes of tests covering 20 different types of fairness requirements, Verify ML fits easily into your existing Python workflow and favorite libraries. It helps you improve model reliability and give you confidence and the peace of mind that models being deployed from development into production meet certain set out performance and fairness criteria. It also adheres very closely to the MES fairness objectives, both in the spirit and the requirements of the FIT principles. So let's see what it looks like in practice. There are 3 components to the Verify ML workflow. It starts off in a survey form, which gather inputs and aligns stakeholders across product, data science, and compliance. These inputs get moved into a model card, which acts as a source of truth for model details, quantitative and qualitative analysis. This then gets translated into model reports, automated documentations, as well as a test suite, which performs automatic monitoring and review. So having understood the process, now let's take a look at a video demo of a transaction fraud case study. Can we play the video, please?
The business is interested in building a credit card transaction fraud model that reduces the false positive rates compared to an existing rules-based approach. We use a credit card dataset that contains age and gender as protected attributes. For the performance metric section, we're interested in recall and precision. Onto the harms and benefits. We note that the false positive cases will be temporarily affected and they might experience delays during the investigation process. New or elderly customers with less credit card data might also have a higher false positive rates. The business teams thus sets 2 fairness checks: a minimum acceptable service that ensures the false positive rates for all groups should not be higher than 2.5%, and an equality check to ensure that the false positive rates for the subgroups should be smaller than a 1.5 times difference. These objectives, generated using the web form, are then converted to the standardized model card response data, which can be integrated with our Python toolkit. So let's take a look at how the minimum acceptable service requirement can be operationalized. The fairness objective can be translated into false positive ceiling, which a data scientist can implement using the min-max threshold test. Running the code conducts the fairness test and generates useful diagnostic plots. Our solution also enables easy trade-off comparisons between models. So let's compare the existing model that includes age and gender against the second model that does not. It seems that model 1 performs better in terms of the recall and precision metrics, but it also fails the subgroup disparity test. So if we were to go with model 1, we should further examine the reasons to justify the use of the protected attribute. For example, elderly customers might be more prone to be targeted by scammers, and using these protected attributes help us identify victims more quickly and accurately. As more investigation is done and business objectives refined, the model card also finally reaches a final state where teams can be comfortable and aware of the trade-offs that they are making. So this is summarized in this final model card that shows information about the model details, the considerations being made, the data sets being used, or quantitative analysis, explainability results, and fairness checks that we have previously shown.
All right, to sum up, Verify ML aligns between business owners, data scientists, and auditors to cover an end-to-end machine learning workflow. It helps you add safeguards into your machine learning practice, increase reliability, and helps you achieve fairness through awareness. So with that, I'll conclude my presentation, and I'm happy to answer any questions you might have. Thank you.
Thanks, Timothy. All right, judges, any questions? We have one from Hans.
Thanks, great presentation. I really like that. So maybe a couple of things I'm just looking for you to expand on. One is I like the open source element in terms of you open sourcing, and I'll be keen to see how you're looking to, in effect, govern or make sure that it continuously evolves in its applicability. And then as you're weaving that, the other part I'm also really interested in is how scalable do you see the solution that you put out at the moment is for the various challenges that are out there?
Right. So I'll address the first question in terms of the open source part. So I think, like as you mentioned, I think the open source element is really a key initiative of our proposal, because we think that by having different financial institutions come together, aligning on a common set of schemas, aligning on a common set of methods, and making that transparent to the users onto how these are being conducted, how these analyses are being done. Going even beyond fairness, I think that adds a great deal of transparency to any banking process, and is a big differentiating factor. In terms of the governance element and how we are looking to take it forward, I think one aspect that we are looking for is actually greater contributors. We just started this project because of the Veritas initiative. This is just 1 month in development, but already we have quite a bit of people interested in it, and we're looking to get more partners on board, both in terms of contributing methods that they see are useful for them, and in terms of coming up with use cases that can be built on top of these methods. A lot of it also owes a great deal of contribution from like Google's team, who contributed like the model cut approach, and different other metrics that we got from other open source software. So we are building on existing works of giants, so to speak. To the second question on scalability, I actually have a slide for that. So if we could transition to slide 15, please. Slide 15. Right, is that the slide? Okay, that's probably not the slide, but right, so it's one slide before, I believe. Okay, so basically what does the solution look like at scale? So we presented the idea in the open source version, but we think that when it comes to scaling it up, basically each team or each data scientist building a project would be responsible for a certain model cut that's committed into Git or any of these tools. And even your third-party suppliers who are building or helping you build models can also adopt the open source toolkit and adopt the format very easily. As a bank, you would then have a central model cut store, which contains all the documentation about all the models that have been done. And you can use that to also easily cross-validate against what has been previously created, and also use it to make sure that future models that are being developed on also continues to exhibit similar performance from both development as well as in production. Just want to add one more point with respect to the previous question on like areas of expansion. I note that for this Veritas competition, we only implement methods as it relates to binary classification models, right? Because that is really the lowest bar currently available to us. I think going forward, we'll be very interested in applying it to wider ranges of problems, including like regression problems, multi-class classification, going beyond going into unstructured learning problems as well, such as clustering, anomaly detection, etc. So there's a lot of scope actually to cover.
Thanks, Tim. Any other questions from the judges? Oh, Zikin, sure.
Yeah, thanks. Yeah, I wanted to bring you back to an earlier part of the presentation, because you mentioned that one last stage is really around monitoring and how the model cards will be updated, and that will help with monitoring. Can you? I don't think I caught that in your presentation. Can you explain a bit more about how that portion is supposed to work?
Sure. So the idea behind it is that the model card is just a very standardized way of representing the data. And so we combine, as part of the scorecard approach, we actually combine it with GitHub actions and workflows, such that on every change to the model, on every code update that's being done, that's pushed to Git, we can automatically run this GitHub action and make sure that the new model being pushed, being updated, actually passes the list of fairness checks that you have set up, that you have intended and you have set up for it to be. So we can be sure that future runs of the model continue to meet these performance as well as fairness measures. Going on to the production stage of things as well, the concern over there is in terms of like model drift or data drift, as well as like degradation in models performance. So we have explicit methods in the toolkit to support that in terms of like model drift comparisons, data drift comparisons. And you can think of it as a hygiene check for your model's performance by sort of automating these checks that they are going into production, say on a 3-month basis, on a 6-month basis, and pushing these audited reports back and making sure that you continue to pass them in order for you to say that the model is performing as you intend for it to be. So I hope that's clear. Thank you.
Hi. In terms of usage, then if I understand well, it's an open source library, right? So it can be imported. It should be part of any type of code that any data scientist is actually creating in the organization to be able to have a scorecard that is actually, you know, cross comparable. Just one question regarding that, right? You know, when you're talking about pushing the code to a GitHub, it's a public GitHub environment for this to be able to work? Or?
No, it doesn't have to be. Definitely not.
Okay.
Yeah.
Okay, thank you. That was my question.
Sure.
All right. Okay, we can have one more question from Ben.
Maybe just a short one. And by the way, thank you again for the presentation, which I thought was really great. I'd like to pick your brain on one topic and thinking more a little bit about desirability from the perspective of the bank, since we're on the topic of fraud. So this could be credit card fraud, could be identity theft, etc. So in a way, there's a trade-off here, right? So you have often very vulnerable groups, which are just very prone to fraud, sorts of financial crimes on the one hand side. And then you have the potential actors actually conducting that fraud. And so since we are talking about fairness, if I take the perspective of a bank, how would you sort of pitch to the bank why they should care in this particular context all that much about fairness? It'd be great to get your thoughts.
Sure. I think that's a great question. And in fact, I covered a lot of the presentation on that aspect of things. So I think the first one, right, is in terms of justifying the protected attributes being used in the model. For example, for the credit card model, one might think that if you were to follow some of the guidelines and you might omit certain protected attributes, it might lead to a degradation in model's performance. One could ask whether that is actually fair or not, right? And by fairness over here, I mean that it's actually that all customers, right? So there are two ways of thinking about fairness in the example. One is that the differences between the subgroups, say age subgroups, have a very disparate difference, have a big difference. But the other way of thinking about fairness as well is that whether each group actually benefits compared to the existing status quo. And so that's like a common argument, for example, in like vaccine efficacy and things like that. From that argument, from that perspective, it actually makes sense to have the age attributes as part of the model, despite maybe it performing poorer on the elderly. And when you actually look into the data, you probably find that elderly customers are more likely to be targeted by hacks and scams. And so that leads to actually a better understanding of what's going on and the true cause of these higher false positive rates. Banks can then take a more proactive approach and actually clamp down on and actually include such variables so that they can detect fraud at a point of time of transactions. So this will benefit both the customers as well, both their customers who would then have like reduced fraud rates, or they also benefit the bank with save on like cost as well as time in terms of getting a better model.
Thanks, Tim. And thanks, Ben, for the question. All right, so if that's the end of the presentation from Xiling, so thanks so much, Timothy, for all your effort. Right now, we're going to bring in the next two teams, but first, of course, starting with Experian, and they'll be tackling the problem statement of loan origination and KYC.
Good evening, everyone. This is Team Experian here to present our fairness solution. We've been working in the area of fairness for the last 4 years, focusing on developing our IP, product, as well as client implementations. Today, we have our London and Singapore Data Labs teams to take you through our fairness solution of the hackathon. A little bit about Experian. We operate credit bureaus as also decisioning solutions for our clients across the world. We've also expanded into offering alternate database underwriting solutions, which we call as PowerScore, to our clients. And what we've also done is provided all that analytics expertise in the form of applications or apps that we offer on our Analytics and AI Workbench, which is Ascend Intelligence Services, or AIS. Fairness is a service the product that we've used in this hackathon is something that we offer through our AIS platform. On our fairness approach, our focus has been to make lending decisions fair across protected groups as well as vulnerable groups. When we look at alternate data, it brings in new challenges like platform adoption and across age or other groups. And this needs to be addressed. Now, what we provide in our fairness approach is a very simple means to address this and for clients to actually be able to implement and go live with fair models. In fact, talking about that, we have this example of Tesco Bank in the UK, where we actually helped the client build a machine learning model, which was better in terms of fairness as well as performance. And this is something that is live and is being monitored by the client today. Having understood about the client implementations of fairness, let's talk a little bit about the product. If I have to describe the product in one word, this would be simplicity. Simple to build a model, deploy a model, as well as monitor a model, in addition to being able to correct for fairness in 4 very simple steps. In fact, what we'll do is let's go through a product demo to understand the product functioning in more detail.
This is the user interface of AIS platform, which offers a range of ML techniques with multiple features, adding to the flexibility of the tool just at the convenience of a click. Additionally, it also supports users to directly code through the embedded notebooks and develop pipelines as per their requirements. Moreover, if we click on the fairness chart on the left, then the tool takes us to this page where it gives us the flexibility to select the fairness metric of interest and see the impact.
Having seen the product in action, let's get under the hood to understand the 3 unique highlights of our fairness offering. The first is the explainability module for identifying variables which increase or decrease bias. The second one is our proprietary grid search approach, which helps to optimize for real-world fairness. That is not only optimizing model fairness, but also models and business policy fairness. The third one is normative data set approach, again to address a real-world problem. A lender may estimate the distribution of the underlying protected group for their portfolio. In fact, during the hackathon, for Singapore and Indonesia, we have used census data to create normative data sets. This uses protected group distributions at a zip code level. Also, during the hackathon, we've, for fairness correction, apart from our proprietary grid search approach, we applied 2 other approaches in the hackathon to compare the results. In fact, going over to the hackathon results, we worked on the hackathon home credit dataset and built a model for the new to credit population to study the impact of alternative data. We focused on a fairness target of average odds difference of 0.95 for the 3 protected groups: age, gender, and marital status. We also tracked for fairness metrics of equality of opportunity difference and disparate impact. We saw that UBR and grid search came out close to achieve the desired fairness and model performance. In fact, on further cost-benefit analysis, it shows that UBR provides the most fair and profitable solution. With this, we conclude our presentation and are now open for questions.
All right, so we have the Experian team on the call with us right now. So we have Dalil, Pietro, Javier, Chen Xue, and Shadab. So feel free to ask any questions, judges. Johnson?
I'm just wondering, what is the tech stack underlying this solution?
So basically, so Salil here, thank you. So basically, we have a cloud-based analytics stack where we are hosting the database on the cloud, and whatever client data or nomadic data that we're using is running from there. It's basically a couple of S3 buckets, and on top of that, on the AWS cloud that we're using for the solution hosting.
Yeah, thanks. Just a quick follow-on question. I think given the use case that you're focusing on here relates to, I believe relates to loans and lending, right? I'm just wondering, is it capable of advising the users on how to apply the different types of fairness metrics?
So for that, it's more of a qualitative framework discussion depending on the regulatory context. So actually, if I have to take a step back, depending on the kind of metrics will be decided by the regulatory context. Is there a specific regulatory ask that's coming in? If that's not there, then yes, what we will recommend from the basis of our research would be a specific metric from a fairness metric point of view that we provide in the solution. But from a flexibility point of view, like what we did in the hackathon, while we targeted one metric, we have the other metrics available for tracking also that can be used.
Thank you.
All right, Junkyung.
Hi, quick question, because I saw in the material you sent about mentioning about alternative data. Can you comment on your experience here and using the alternative data and to achieve the intended outcomes that you are showing here?
Sure. In fact, thanks. In fact, a great question. In fact, we've been working in the space of alternative data for now about 5 years plus, where we've actually had live models going in. The way we look at alternative data is from a purpose of lending. There is financial data and then there is non-financial data. And we've worked on alternate data sets such as telco data, utility data, banking transaction data from a financial perspective. And from a non-financial perspective, we've had a look at the digital footprint and a lot of times the SDK data set. What we found is that some of these data sets, essentially wherever there is a financial intent clarity coming in, we've seen a lot of good value come for especially the emerging markets, where we've seen this value in terms of predicting credit behavior. That's something that we've seen, and we actually have, as we speak today, we have about more than 20 clients who are actually using alternate database scores here in APAC, which we provide. And alternatively, we also have similar alternate data clients in EMEA and other markets also.
If I may also build on my name is Javier Campos. I'm the head of the UK Data Labs, but I also belong to a commission by the Bank of England and FCA that we are putting together a roadmap for artificial intelligence. So I have all these discussions with the regulatory here in the UK. The metrics are different per country, and in terms of the alternative data, there is a lot of, I think one of the challenges you're going to find on the solution is to test a lot of the metrics on fairness. You don't have the data, clients don't have. So for example, if you want to test, is my model discriminating people from the LGBT community? You could want to test that, but the reality is you don't have the data who belongs to those communities. What we found, and this is one of the USP of this solution, and we've done quite a lot of work over the last few years, is creating this alternative and normative data set. We can infer how the distribution of these protected groups are, so you can actually check that your models are or are not. And the other thing, the last thing on that one, you can also use this solution to help financial inclusion. Financial inclusion can be seen as another protected attribute, so you can actually model your population who is financially vulnerable. For example, in the UK, there is a big push from the regulator, and you can use that tool to do that, to make sure that your models are actually being financially inclusive and they're not excluding people that might be vulnerable under certain categories.
All right, Lachlan, please.
Thanks very much for the presentation. In just following up on that, this normative data approach where it sounds like you're inferring membership of protected attributes. Could you comment on perhaps the ethical risks of that, especially in light of like the cases where people have inferred, for example, gender or sexual orientation from demographic data and had sort of that kind of blow up?
I have this discussion very often as well. So I will just comment from the sort of business point of view, and I will pass to Pietro, which is our principal data scientist, who can tell you on the technical why we. I think the way to do it is the positive at the moment, because, and this is part of there is a bit of a sort of contradiction of the regulator. They tell you don't discriminate, but they also tell you don't gather the data because you can make mistakes. But the problem is, if you don't gather the data, you cannot know. So I think the way to do it is, yes, there are risks, by the way, and I will let Pietro in a minute to talk about what we do technically to really minimize, but there are risks for sure. But the sort of the way to do it is, look, today there is discrimination for sure happening in a lot of ways. That is not being looked at. You have this harm today to the consumers. By looking at this technology, you can at least, sort of address it. Amazing that you can do it. So I think it's a question of weighting a balance, the risk between, if you don't look at it like what you do now, you will discriminate, and that happens actually, and we have proof in a number of areas for a number of protected attributes. By creating these models, you can actually help make it a bit better. It won't be perfect, and there are some risks, but technically we do a lot of stuff to prevent that. And Pietro, if you don't mind complementing the technical details.
Yeah, please. It's just I guess it's there are 2 points. One is that we did not really collect any new data. What we are using is collections of public data and data that Experian already had in order to basically support this new use case. And the use case, yeah, it's just that there are very, very important, very good reasons for which a lender might not know, for example, the ethnicity of their customers, but they might want to know if their model on average discriminates against them. And that's exactly the point. So we don't collect data on individuals. We just use probabilistic labels that are based on aggregations. Then on top of that, we had built probabilistic models. It's Bayesian models, basically, that can estimate the posterior distribution of some fairness metrics. So that's the way it actually works. We know from some characteristics of the customer that are actually collected what the probability of them being in this or this other value of the protected attribute is, and then we use this probability and our Bayesian models to make statements on the average behavior of a model or of a data set with respect to that protected attribute.
Thanks, Pietro. All right, so that's about all the time we have for Team Experian. So thank you all so much for the great presentation. And we would like to bring in our next team now. Also tackling the challenge statement on loan origination and KYC, we have EY.
Hello, everyone. My name is Aparna Mishra. I'm part of EY GDS. I'm an AI leader there. With me, I have got my team, a team of data scientists. I have got Tina, Ankita, Kaustav, Satya, and Kinjal. All of them are data scientists, AI architects, and them work in that capacity. So the problem statement that we have received and we have worked on, that's the KYC and loan origination. I will walk you through the solution, what we have built. We can move on to the next slide. Yeah, so that's the introduction which we have done. Yeah, so that's the first slide. If you all can view the screen. The objective of this particular study is to really develop one particular framework which allows you to analyze the fairness dimensions on any particular AI model that is developed. I'm sorry, but somehow this screen is not so visible to me. It is very blurred. So if someone can help from the audio video team, that would be great. The first part which I would like to cover, that's the definition part. Now, with respect to the definition, what we have analyzed here is that The fairness can be analyzed in multiple aspects. The aspect what we have selected, that's the categorical way, where one particular model, AI model, has been, the scores have been used to accept or reject KYC and loan application. Again, within that, there are two more dimensions of definition. We have developed two models for loan application, loan creation model. Gender is the protected class, which we have analyzed. And there is another monitoring class, which is the less than 39 years of age. And the second model, which is the KYC model, for KYC model, race is the protected class, where again, the same demographic or the age group gets monitored. The data is all Veritas recommended, that is the Kaggle data. The model, we have tested it on different algorithms. So mainly we will be presenting three algorithms, the comparison and everything what we will be doing. We have done some amount of enrichment in the data, and that enrichment is from the credit bureau. And that's the publicly available, again, data set what we have used. The framework contains three major components. The first component is bias detection. Bias detection has got, again, within that, there are three components. One is the visual way of detecting raw data, performing correlation. Then another one is the statistical evidence of bias. So that's the detection part. After that, we have mitigation. That's the second component of the solution. Within mitigation, there are two components majorly. One is the stratified sampling, and another is the constraint optimization. Now, things related with constraint optimization, that is the what-if analysis, where you really decide that what are the kind of trade-offs business would like to operate on. And the last component of the framework, that is nothing but the fairness monitoring. Once you put your solution onto the production, how do you really monitor and ensure that your solution is unbiased? So what you see now on the screen, that's the mitigation framework. We start from checking the explicit biasness. Now, explicit biasness is nothing but making understanding if there is any presence of protected class. Then that's the explicit present. And the second one is the implicit bias, and our scope of framework development and everything that relates to the implicit bias. Now, implicit bias is nothing but what it tells is that without having the explicit biasness, there could be certain variables in the model which will still be impacting the decision outcome for those protected class variable. In this case, it's gender and race. So we start the check. That's the number two. We start the checks on the implicit biasness, which has got three components, which I have already: graphical correlation and linear regression. These are the pseudo linear regression. I think I'll explain it in the next slide slightly better. If there is explicit bias for our case, which is the KYC and loan origination, gender was not something which should have been there in the model, so that has been removed at a first step. We move on from there, and then implicit bias detection. If it tells you that there are certain variables which have to be dropped, that's the second level of elimination which can be done. And then from there, but not necessary that is still you can handle bias. So we move on, and then we have to still mitigate that bias. And to mitigate that bias, the first component is the stratified sampling. Using the stratified sampling without changing the population composition, we have stratified in such a manner that you can basically boost up a bit of your population. I'm sorry. Yeah. And then thereafter, we have the constraint optimization. Constraint optimization is that we can select one particular fairness matrix. We can work with that matrix in such a manner that both the groups have got the balanced one. And then thereafter comes the what-if analysis, which is the trade-off it will give you. And with that, at every stage, we have to make sure that this bias detection checks are performed and we are able to do justice with the data. This is the bias detection. Very briefly, I will touch upon point number 1. That's mostly the raw data checks of approval rate, odds ratio, and everything. Second one is the correlation. And I would like you all to take a look at the center block of this correlation, where we have calculated 2 types of correlation. One, female is coded here as 1, and male is 0. Now, you calculate the correlation with the original data in the training data, and then the same, you do the correlation with the predicted score. If these 2 appear very far from each other, there is an indication that there could be a bias. But in this case, these 2 are very close to. And another one is the next chart, where you see this line, crisscrossing each other. What we do is that when these 2 lines, they appear far from each other, again, there is an indication of the bias presence. And after doing first and second level check, not necessary that, I mean, if they are not showing bias, still you can never be sure that there is actually no bias, because in any multivariate scenario, things can be very different. And that's the purpose of the third step, where approval has been regressed as in function of explicitly on the protected class, and then the highly significant value, as well as the sign of that coefficient, that tells you that there could be a presence of the bias. We go on and then we regress it on the gender. Now, if again there are variables, the X side or the right hand side variables, those who would be impacting the gender, the coefficient and then the sign of that particular variable will tell. Now, this entire framework is basically to really understand that where, in what form and shape, implicit bias could be available. And then you have the last block is the comparing it by the algorithms. Sorry.
All right. Sorry, Aparna, is it okay if you can just help to summarize the presentation and we can move on to Q&A, being mindful of time?
Sure. Definitely we can do. So I would like to, so mitigation, I would like to summarize it, where I think I have already spoken about these 3 techniques. The first one is the stratified, where we have, you can just check now the third one, let me just talk a bit more, which is the what if analysis. Now, we have analyzed this what if analysis basically to understand the trade-offs between the business accuracy, fairness, and those kind of outcomes. Yeah, and this is in particular, I wanted you to maybe take a look. I'm sorry, this technology is not helping me. Yeah, so a trade-off has been performed at 4 levels, and there are losses, gains, and all of that can be analyzed. And end of the day, we have to understand if you have different techniques you have applied, so which one is closer to 0%, which is like bias free. So that's the trade-off. And other than that, we have the monitoring and control. So once you have the production data available, you are using this particular model, then there is a population stability index, character stability index, and data drift. All that analysis you can perform by gender. And all in all, this is the overall framework which allows you to, it's a control framework, I would say, not a single methodology that gives you a decision around whether you have bias in the model or not. But it's rather, it's a question of applying the right tools, techniques, and everything, and be able to understand that in what form and shape bias exists and how do you address. The solution is fully scalable. I think that is what I can say. It is fully scalable on any type of business problem. You can do that. So I would like to just play a video if that's possible.
Hi, this video presents a fairness framework under FEED principles on loan origination and KYC data. It ensures fairness at model development as well as production stage. The usual AI black box model can at times be biased. We have 2 different loan applications scored by a black box AI model. One is rejected and another one approved. We observe that the 2 applicants have same attributes except gender. Fair AI framework gives equal weightage to both model and fairness matrix. We see the same 2 loan applications are no longer discriminated by a fair AI model based on gender and predicts the same outcome. The components of fairness framework include bias detection, mitigation, trade-off checks, and monitoring and control. The first step is bias detection. It includes graphical checks like gender-wise comparison of loan approval rates, odds of approval, and checking of other fairness metrics like equal opportunity, predictive parity ratio, etc. After bias detection, mitigation is performed. Here we have three different strategies: stratified sampling, constant optimization, and what-if analysis. What-if analysis provides a trade-off between the fairness matrix and business objectives. A differential threshold can be selected for different groups of protected class to ensure balance in decision outcome. Finally, for seamless working in production, the model and fairness matrix are monitored continuously to identify any data drift resulting in model recalibration and fairness assessment. Some benefits of this framework are fairness definition flexibility, transparency, high scalability, and many more. To conclude, we have presented a fairness assessment and control framework in KYC and loan origination decision making. Thank you.
So
All
that
right.
is it on the presentation. Yeah, thank you.
Thank you, Team EY. Being mindful of time, we have to actually shift over to the next presenter. So thank you for the very comprehensive presentation, Team EY.
Thank you.
Thank you very much. Welcome back, judges. We're very excited to close off with our final wave of presenters on the topic of risk, compliance, and fraud monitoring. With us, we have Team Eisen, SAS, and True, Era, and The Mist. Starting things off will be Team Eisen.
Hello, my name is JS Khan, the CEO of Eisen. So through this global Veritas challenges, we have developed the RFIS, Asian Reinforcement Learning Fairness System, improvement system, where the performances of fairness can improve automatically with the technology and while maintaining the accuracies. So we have conducted this project through the 6 phases, and we have focused on the 4, 5, 6 phases mostly. So the process-wise, we have developed the model using the basic machine learning technologies. And on top of that, we added up reinforcement learning layers where the features that personal features that can be subject of the fairness can be improved while maintaining the accuracies. And after that, we have implemented API prototypes in the APIC sandbox. And we have dedicated our team for the last several weeks, and are led by YS Park, who is leading the risk and information technology stacks, and who is having covered the very niche financial expertise in the finance areas, especially credit scoring. And we have selected home credit default risk as data sets. And this data set has we have developed our system based on the guidelines provided by these challenges. And one of the objectives is to maintaining accuracy and improving the fairness parameters. Okay, and then we have selected 2 parameters as an indicator to improve. One is the average odds, which is an indicator of the fairness. If the number decreases, we identify the fairness issues can be improved. And at the same time, we control the balanced accuracies because we need to keep the accuracies at the same level. So we pick up the gender issues. This parameter attributes are inherently biased in some ways. And we, based on our base models, there's a potential benefits and harms. And based on our base models, we have developed our initial model. And then through our existing system, we have picked up the 5 important features that is impacting the accuracy of the models. And based on these 5 parameters, we have laid out the numbers that is guided by this challenge. And if you look at the gender issues, the average odds is 0.125, which is the indicator of the fairness, and a balanced accuracy is 0.65. So we're going to show you that how the bias issues in the gender issues can be improved using the reinforcement learning system. The system is composed of the two parts. One is reinforcement learning stacks and the incremental learning stacks. The reinforcement learning stacks, we have used DeepQ network algorithms where we set up the environment and actions and rewards. The rewards is the gap between the fairness after iteration of training sets. And the incremental learning, we have used the tap algorithms because the data set is more like suitable for these algorithms. And the next page, before we could move on to the next page, the left-hand side, we're going to show you the real-time training demonstrations on the left-hand side. And after each period, end of each episode, the fairness and the average odds and the accuracy is marked down in the right-hand side. Okay. And then please click on the demonstrations from your side.
This video demonstrates how we can achieve the fairness objectives using ASIN Reinforcement Learning Fairness Improvement System. The chart on the left shows our fairness metric average odds and the performance metric balanced accuracy for every step in one episode. It runs one incremental learning process for every step and measures the average odds and balanced accuracy of the classification model created from the training result. One episode ends after 30 steps, and we track the result at the end of each episode as shown on the chart on the right. The result is the mean of average odds and balanced accuracy values of the last 10 steps out of 30 steps. The policy updated during the episode affects the agent action of the current episode. The agent takes either exploitation or exploration action. Eventually, more exploitation and less exploration are performed, as the epsilon threshold is lowered. As the learning progresses, we can see the average odds gradually decreases as we increase the training time. This indicates an improvement in fairness, while at the same time maintaining the model performance. It automatically searches the best model with an optimal fairness value, deploys, and uses it as a credit scoring model.
So we try to make a very scalable we try to make a very scalable the system because the personal attributes that is subject to fairness can be different, like country by country and industry by industry. So we try to make once we identify this parameter is a subject of fairness, it improves automatically because it takes a lot of human efforts. We try to remove that kind of efforts. So after that, every single algorithms trained and deployed need to be monitored, and the performance need to be tracked. So in one single technology stack, we are providing all these informations, the accuracies and the previously trained models. And each algorithms can be implemented using our API stacks. And then that's the performances is monitoring through our system. So this gives a lot of values for the financial institutions. And then we already implemented this kind of basic like a technology stacks to around the very traditional the banking institutions in function-wise banking, payment and insurance and asset management company and even government side. And it is very challenging and very difficult to apply this reinforcement learning system into the credit scoring, but our team has successfully demonstrated the potential and the powers of these AI technologies can be implemented this kind of a very critical part of the banking finance sectors. So this is the end of the presentation, and it'll be very much appreciated if you can raise any questions about this the system.
Right. Johnson, please go ahead.
Hi, thanks for the presentation. My question relates to the enhancement process with regard to your fairness measure. So how does the reinforcement learning impact the performance of the model with regard to the accuracy?
There's two types of parameters we need to monitor. Okay, so there is a trade-off between the fairness and accuracies. So our objectives is to maintaining, improving the fairness, and then while maintaining the accuracy. So we are trying to find the optimal points that has not been searched in the previous very general algorithm. So every iterations of reinforcement learning, the system automatically points where the fairness can improve, and while the accuracy maintains at the same level.
Sure. Thank you.
All right. Lachlan, if you could get Celine to go first, if that's okay.
Yes. Hi, thank you for your presentation. I was wondering about, how do you actually ensure the accuracy and the maintenance, right, of the model, and how do you monitor that, especially when it comes to the, control function in the FSI industry?
So your question is that how to maintain the accuracies.
How to ensure, how to monitor. Sorry.
Yeah, so the later part of the presentation shows the real-time monitoring system. So, okay, so at time now, we agree that this model is enough to implement it, right? And after it is implemented, there might be some environmental can be changed, right? So population shifting index we need to monitor, okay? And then KS and the ROC, whatever informations we need to monitor, right? So every time has passed, the system, the boxes, small boxes, embedded all the information regarding that kind of accuracies, the number that has been developed, and then the number that is implementing. So there's a gap can be monitored in the system level. So if the gap reaches a certain point, that system alerts to the operator that this model should be replaced.
And we have time for one last quick question from Lachlan. Oh.
Thanks for the presentation. There are some theoretical results that bound the trade-off between fairness and group fairness measures specifically and accuracy. So could you speak to how your algorithm is getting around those, or whether they are?
Yeah, so theoretically there's a strict trade-off. If the fairness improves, you need to sacrifice balances, right? So we need to overcome this kind of limitations of theoretically. So we have used the reinforcement learning where the automatically sampling out small batches, okay? And find the optimal points that has not been identified using the traditional way. So using this finding the optimal points, trade-off points where the remaining balance and improving the fairness is where the technology AI can overcome the heuristic way.
All right. Thanks so much for the questions, judges. With that, that's all the time we have for ISN today. Jung-Seok, thank you so much for the great presentation. And now let's bring on our second last team for today, SAS Institute.
We're honored to present our solution prototype, the IADA framework workflow. Our prototype focuses on SME sole proprietors because they find it difficult to access finance and are unfairly excluded from the credit scoring and profiling process due to having thin data files and get considered high risk, and by financial institutions increasing their use of AI that often relies on using alternative data. And both the AI and alternative data may have inherent bias. So our solution approach provides a flexible, scalable solution that embeds feet throughout the model lifecycle. To mention here is that it can be applied to any consumer or corporate SME risk portfolio and evolve with maturity of a bank's responsible AI journey. The solution enables lenders to balance their business objectives with fair and reasonable, responsible lending that considers the borrower across the spectrum of fairness, bias, and vulnerability. And as shown on the far right here, to balance fairness with more the business objectives, our solution produces a range of fairness metrics, embeds fairness in the end-to-end model lifecycle and decisioning process, and uses powerful tools to perform 3 key tasks, including but not limited to careful analysis of protected variables. Importantly, our solution approach integrates FEAT principles across an ADA workflow prototype to ensure decisions made by models in the decisioning process are safe, automated, transparent, and fair. In this diagram on the left, we show each approach taken for all tasks of the workflow, including those for data, analytics, machine learning algorithms, and monitoring, and as well as all assets. And on the far right here are details of 6 steps of the workflow. The solution is a minimum viable prototype that can be integrated into a bank's risk management and corporate governance framework and can be applied to SME loan acquisition as well as model ops. When needed, the solution can be extended to accommodate further features of FEAT, bias, and vulnerability across the credit risk lifecycle. And all key features of the solution are shown here on the far right. The prototype is based on award-winning SaaS solutions that are tightly integrated, easily extended, and operate at enterprise scale. And a sample of our reference customers that use components of the prototype are shown here on the far right of this slide. The ADA framework workflow is composed of 5 steps. One of the steps includes update of the fairness dashboard and review of it by a model risk specialist. And other key personas that make use of the workflow are also shown here, along with their particular tasks that they need to perform. The scenario for our prototype is that data that's used to externally score SME sole proprietors is assessed for hidden unfairness and bias. And we will now play the prototype video clip. Thanks. That's you. Answer questions.
All right. Oh, okay. So Celine has a question.
Yes, hi, hello. Thanks for the presentation. I wanted to ask what is the tech stack behind the solution?
Sorry, can you repeat that?
Sorry, the tech stack that is behind the solution, is it based on SASVIA, or is it something that can be open source?
Yeah, it's all supported by SASVIA. That's correct.
Okay, thanks.
Any other questions from the judges?
Okay. Just on the question, sorry, on the part when it goes with the trade-off between the system fairness and then the business objective. I didn't catch that in your presentation.
So what's the question? The balancing that's
regarding the trade-off,
achieved?
right? Like how can we actually look at the trade-off between being fair versus incurring too much risk? I would say.
Louise, are you on the line? Do you want to answer that from the prototype perspective?
Sure, I am. Okay, so basically, can you hear me? I hope you can hear me.
Yeah.
So basically, once you configure the first interface that you saw, and the video is very fast. So basically, the first one is the governance interface. So by configure the business objectives there and the project scope, the solution is able to access something that we call a model card. And in this model card, we'll be able to actually confront what is happening with the model, what are the bias that we saw. So for example, in this use case, we found some hidden correlation with protected variables, but we also need to evaluate using the trade-off analysis to say, okay, what is the variable that is bringing this correlation? In this case was income. So the owner income is actually bringing correlation with protected variables. But what is the objective of the model? In this case is reducing the probability of default. So monthly income is actually decreasing the probability of default for the applicants or the SMEs. So we were able, by the trade-off components, actually include additional variables. And actually we use some alternative data from the SME that in the case was financial supplier information. And we could on the fly update, change the monthly income, remove this bias, and actually compare, the final in the final step in the video check, actually doing a trade-off analysis. What is the lift of the model when I remove this owner income for this supplier information? And basically, and this generates this model card, the reports that you saw. So in the same interface that you have the business objectives, the model reviewer will be able to access that. And okay, the feedback is actually you accept this new suggestion and rerun and recalibrate the model. So basically, you send back the model process for the model owner.
Okay, we have two questions. Junseong, you can go first.
Yeah, just a quick one to clarify. So this is a bit like a ready product that you already have out of the box, and as part of this Veritas challenge, you basically executed using the base product to get the result that you're seeing here. Is that, and how many % of that is really a ready product? I think before this Veritas challenge.
Well, I can say like.
So you go ahead, Louise, and then I'll jump in. So yeah, we've used as much of our standard functionality, and then we've also obviously tailored it towards a prototype to address our particular solution approach.
Sorry, I think I couldn't hear very well. I think maybe in terms of the percentage of what is already what we are seeing today, how how many % of it is already like, how much of a customization you need to do to get the use case that we talk about here?
So from a customization perspective, it would be minimum, maybe around 5%, but then there is a level of configuration. So out of box comes around 80 to 90%, and then the remaining is configuration or customization.
Thank you.
Johnson, would you like to ask a question?
Yeah, just a quick one. On this particular use case, what was the fairness threshold that was applied? Because I guess there was a mention of maximizing the benefit and of course minimizing the harm. So with that kind of context in mind, what was that threshold that is being applied here? Not threshold, sorry, the metric.
Yeah, we've used a number. Oh, sorry, who's jumping in there? Sorry. So we used particular measures such as demographic parity, predictive parity, equal accuracy.
Is there any preference for any one of these measures given the context of your interest here?
No, it's quite broad.
Also, you just broadly apply that
so broadly apply
you leave it to the user
the principles
to decide based on their analysis on what would be the best measure to apply. Am I right to say that?
I mean, obviously, the FEAT principles are quite broad, so we kept it as broad as possible. That we didn't select one over the other.
Okay, understand. Thank you.
All right. So if there are any further questions, feel free to email them to us, and we'll be happy to address it after this challenge. With that, thank you so much, SES team. And we'll now bring in the final presenters for today, which is a tag team between TruEra and The Mist.
Hi all, welcome to the entry from TruEra and DMIST. We've got a video coming up, but first a little bit of introduction to us. TruEra is a company focused on trust in AI, and DMIST is a company with 10 years of experience in external data. As you can see, we've got a bunch of folks who've worked quite extensively in this space. Scott and I led it, but most of the work was done by Ari, who's dialed in from California, 4 a.m., and Prashant, 8 a.m. in New York. So in terms of the problem we're trying to solve, that is to demonstrate the value of bringing together curated, well-governed external data with state-of-the-art fairness and explainability tooling in order to improve fairness and accuracy in credit decisioning. And I do want to spend a little bit of time on why we chose this problem. I mean, we believe our starting position is that fairness in AI and trust in AI is as much as about the data, if not more about the data than about models. And particularly when you're working with machine learning, you're dependent a lot on third-party data. So we thought cracking this problem, how do you build trust and fairness when you're using external data for machine learning models is a key topic. So that's what we're focused on. In terms of what you're going to see today, what you'll see is three things as a starting point. We have a curated data set sourced by DMIST, which is the external data platform, which includes demographic and credit rate information. On that, Ari built a machine learning model, gradient boosting classifier to predict creditworthiness using that curated data set, using the credit rating information as the target variable. And then we applied TruEra's fairness assessment and explainability software, which we enhanced for the hackathon to see how fair and accurate they were. The result was that this particular model was both biased and inaccurate for the chosen protected group. This is based on the US data, so the chosen protected group was Black households, and it was both biased against Black households and more inaccurate for Black households compared to the rest of the population. We then did a couple of targeted mitigation actions, which you'll see in the video, to retrain the model using enhanced data sources. So we dropped some fields and we added another enhanced data set proposed by DMIST. And as a result, we were able to reduce the bias, though not eliminate it completely, and also improve the accuracy of Black households. So that's what you see here. And that small battery bar you see is how much of this was beforehand. So we did have obviously a basic tooling as well as some data set available. But during the hackathon, we focused on building the model, enhancing the tool set a bit, and then, of course, playing with the model and with the mitigation actions. So with that, I'm going to request that the video be played, please.
Hello. In this fairness workflow demo, we do 6 things. 1. Define a protected group or group of interest. 2. Set a fairness objective. 3. Assess relative disadvantage for the protected group. 4. Assess root causes of disadvantage. 5. Conduct targeted interventions. And 6. Analyze fairness versus accuracy trade-off for each intervention. Protected groups can be introduced by creating new segments using one or more of the model's input features or an excluded input variable which is not used for training. In this US-focused example, we chose to treat Black households as the protected group. Note that the percentage of Black households in the training dataset, 14.7%, is comparable to the overall Black population in the US. The next step is to set out our fairness objective. We do this in 2 steps. First, we select a suitable fairness metric from a rich set of metrics available in the system. Then we set an acceptable range for the value of that metric. In this example, the metric chosen is equality of opportunity ratio, with an acceptable range of plus or minus 30%. The next step is to assess whether Black households are significantly disadvantaged compared to the rest of the population. The answer seems to be yes. The equal opportunity ratio is just 0.55, instead of the ideal 1 or even the acceptable 0.7. Additionally, the model is also more inaccurate for Black households, with an AUC of 0.84 compared to 0.94 for the rest of the population. Measuring relative disadvantage is arguably the easy part. Identifying the root causes behind such disparity is more difficult. Zooming in, we look for 2 things: features that are proxies for race, and features that might be difficult to justify due to their black box nature. Turns out that there are examples of both in this instance. The geocode and postcode features contribute more than 1/3 of the disparity between Black households and the rest, and may be seen as proxies for race in the US context. 2 other calculated features, underbanked flag and economic stability indicator, contribute about 20% more to the disparity. These are black box features and difficult to justify. So here we are with a baseline model that is inaccurate, perhaps unfairly biased, and dependent on potential proxy or black box features. What can we do by way of mitigation? 2 things. First, we could remove these proxy and black box features and retrain the model. Second, we could supplement the existing data with complementary alternate data such as tax information. We tried both, with striking results. The equality of opportunity metric goes up from 0.55 in the original model, in green, to 0.66 after the first intervention, in blue, and then 0.71 after the second, in orange. Black households are now much less disadvantaged. Not only that, but we also find that the model becomes more accurate for Black households between the baseline green model and the final version in orange. The accuracy remains almost unchanged for the rest of the population through these interventions. So there we have it, a model that is both less disadvantaged and more accurate for Black households.
So I'm going to answer questions right after this, but just a couple of more slides, if I may. So in terms of why we think this is distinctive, 3 things are really important. First, underpinning this is a lot of external data management best practices, everything from managing consent to the workflow of data and making sure that we can trust the data that is being used. And that is super critical for external data. And DMIS, with their 10 years of experience, brings a lot to that. Second is the fairness assessment and monitoring tool. I think the critical aspect is the root cause analysis. You have a lot of fairness assessment capabilities, but being able to link that to the contributing factors using Truera's state-of-the-art explainability technique is super critical. And then lastly, this is not a proof of concept. It is practical, it is accessible. It's not just for data scientists, it's for people who are not data scientists who can look at it. And it's ready now. It's been deployed for internal data at many clients and the solution from Truera. The external data from DMIS has been deployed for over 10 years now across 50 plus FIs. Bringing this together in a way that actually makes it meaningful to make algorithms fair is something that was new in this piece, right? So that's what we believe makes us distinctive. In terms of what lies ahead, I think 3 ways that we thought FSIs could look at improving fairness and accuracy of IDA models using third-party data. The first is to source well. Do not take third-party data that you don't understand, that you don't have clear end-to-end visibility into the supply chain for data. That's number 1, very critical. So pick a partner like DMIST or anybody else that is reliable. The second is to invest in a bit of pre-processing like this. I mean, in a couple of weeks, you can build a preliminary model, and using software like Truera's or other equivalent, you can actually get a lot of idea about what is or is not good in that data in terms of the potential impact on bias, even without creating the final model. And then the third one, which we did not go into today, is a somewhat radical idea, which is as FSIs in the industry get to know more about individual third-party data sources, perhaps we could think of some kind of pooled intelligence to say, hey, actually, this kind of data is not good for this kind of models. Now, it's a bit tricky because there's a lot of IP considerations, legal considerations, but certainly something that we would recommend that we consider as perhaps as part of Veritas Phase 3. So that's the end of the formal presentation. I think we've kind of done the demo as well. Just to recap the results of the piece, this is the accuracy side on the right-hand side. Accuracy improves from the green to the orange. The orange is the final one. And again, the equality of opportunity ratio also improves. Importantly, accuracy does not change materially from 0.94 to 0.939 in the rest of the population. Lastly, we also did a mapping with the Veritas methodology. We didn't get all green, but we did map our solution against the previous, the phase 1 version of the Veritas methodology. Of course, phase 2 is getting updated. That's it. We have a more detailed presentation, but we're open for questions.
Thanks, team. Judges, if you have any questions for Shamik, Scott, and Prashant, feel free to ask away. Dr. Marie.
Great presentation, Shamik. I think it's a brilliant idea to supplement the training data. And I'm wondering if does the tool provide any guidance on the kind of data that would be appropriate to supplement for the training models? I think beyond the technology, I think this is possibly one of the high impact ecosystem next step solutions, as you well mentioned. Is there an indication of what kind of data might be supplemented?
So I'll let Prashant in particular speak because he was the one who gave that. So I think, Dr. Mary, the current situation is that we did have this in the solution, but it was on the back of human intelligence. So when we went through 50 plus data sources because DMIST has access to 1,000 plus. And it was on the back of the intelligence of the core data team that we realized, well, actually, if you got this kind of data here, you might want to pick this from Atomic. I think that was my phase 3 point, that actually, to some extent, DMIST themselves could kind of publicize their metadata better and say, if you want this, these two are complementary, which they do through their consulting kind of service. But as we get the whole industry together, that might create, that was the third wave piece. But in this instance, Prashant, I remember you advising us because based on your knowledge, you were able to tell us this data will be complementary. Is that right? I'm assuming you have something internally, Prashant, which allows you to look up some kind of metadata.
Absolutely. And Shamik is exactly right. We have an entire data discovery platform that's designed to help organizations basically figure out which data will suit their needs. On a base level, like we would start with the input keys. So what information is available that we can use to combine two data sets, right? First name, last name, address, identification number, phone number, email address. Then from there, we would also then look at the specifications of the use case and data compliance. For certain use cases, there's more sensitive data, whereas for other use cases, you have more of an expansive possibility. And then the third is kind of looking at the specific data sets. Shamik mentioned we looked at tax data here, which is a very unique data asset relative to what's being used generally in the industry today. We also look at a lot of scores around phone verification scores and identity verification scores, which is quite useful globally to help identity verification models, which is another use case. So there's all kinds of different data that we can use for various use cases, and DMIST is designed to help organizations basically curate that, and we've spent a lot of time building the compliance around that.
Thanks,
Scott, if you have anything to add to that, you're welcome to.
All good. Over to the judges.
All right, let's just take one last question from Hans, please.
Yeah, and great presentation. I like the linkage of the data. The question I just kind of had is, how confident are we, or how confident or how much thought have you put within your solution of basically, in effect, protecting protecting yourselves, or a security consideration of bad data creating poor model behavior, as it were, because it's a very different vector from what I've seen, in other places.
So maybe I'll take that. Sorry, for some reasons a lot of people. Yeah, maybe I'll take that. So I think this is exactly what the solution does. So you are able to look at. You couldn't see all of that today in a short video, but you're able to interrogate the influence of each variable right through its life cycle. It's not just top level feature importance, but for example, I'll give you one real life example. At one bank, debt to income ratio was an important feature, as you'd expect. But you could look through the debt to income ratio value and you could realize that actually there's something wrong, because after a debt to income ratio of 30, for some reason, the model is predicting low risk, because at that point, you should not have that. So that kind of ability to interrogate is absolutely in the tool, and anybody who's interested, we can share that. So certainly a big part of doing something like this safely is being able to really go deep into the data and its influence, individual feature by feature if needed, or groups of features. Yeah. I think there was one more. Was it Ben? Yeah.
Will this be a long question, Ben? Because just being mindful of time.
I'll make the answer short.
Okay.
Very short one.
Quick one. Let's take it. Yeah.
It will be a short one. Thanks a lot for the presentation. Very engaging. My question is, additional data could also add additional cost. Have you thought about that aspect? How would you?
Scott, yours.
Yeah, sure. Short answer. There is over 5,000 companies in the world selling data by our estimate. Some of them are incredibly expensive, like the credit bureaus. But there's a lot of really innovative, up-and-coming data providers providing ethically sourced, legally sourced data at individual level, business level, at much more attractive price points, and they're disrupting the market. And so part of what we do is actually cost optimization. How do you create substitutes? How do you create proxies? How do you reduce the amount of data you have to consume if it has to be the most expensive in order to reduce? And then generally, our benchmark number that we've been able to see with customers is from an average spend level, we drop at about 30% through a combination of cost optimizations. So there is ways to reduce the cost. It doesn't have to be just go buy it all from the credit bureaus.
Thank you. Thank you very much.
Thanks, Ira and the team. Thank you all so much.
Thank you. Cheers. Bye-bye.
Thanks.
Big thank you to all our partners, judges, and mentors for their support over the past couple of weeks. And of course, our 10 dedicated finalist teams who have put in weeks of hard work to design meaningful solutions that will drive the implementation of responsible AI in the financial sector. We would like to invite all of you to join us on November 9th during Singapore FinTech Festival 2021, where we will officially be announcing our 3 winners of the Global Veritas Challenge. Stay tuned and watch out for our time slot on the SFF official calendar, which will be released soon. We look forward to seeing all of you on the 9th of November. Until then, take care, stay safe, and see you soon.